Hello everyone. Today I'll be walking you through this Python notebook, predicting the stroke status as the binary outcome variable. And also I'll be covering the steps I took to improve and assess my classifier performance and then fine tuning it. So let's dive in. The first two steps are just quite straightforward, just loading the required libraries and loading the training and data set. Then I use the info function to have a holistic view of the data set. And I checked if there are missing or duplicated values. Fortunately, in this data set, there is none. And then, so let's jump into the exploratory data analysis. Firstly, I focus on the target variable stroke. From the histogram, I found there's a severe imbalance between the two outcomes, which needs to be adjusted to using oversampling in later steps. Then I check the distribution of the predictor variables to see whether there are outliers, since outliers will significantly weaken the credibility of our models by introducing the bias predictions. And a correlation matrix is also included to identify the variables with higher correlation. This step will help us in choosing the features to construct the model, probably. And for the categorical variables, I check the unique values in each variable so that I will encode them in the data processing step. If it is a little bit tricky for the variable gender, there's one observation unknown, so I just simply decided to drop it. And for the data analysis, for the data processing, I encode the categorical variable features dealing with the outliers. I choose the Turkey rule to exclude those data outside the range between the first quartile minus 1.5 times the interquartile and the third quartile plus 1.5 times the interquartile. After that, I apply the standard scalar to standardize the numerical features. Minimax scalar is used for normalization and the robust scalar to robust the outliers. Now I need to fix the imbalanced distribution between the two outcome classes. From the IMBler library oversampling, there are a couple of methods. Then I need to test each of them to get the best one in this scenario. And also note that the k-means and the k-means mode and the smoke NC cannot be applied here since we have converted all category features into numbers, and there are not enough clusters. To construct the model, first I choose the library of py-caret to evaluate the models from a high level. The output shows that the light GBM gives the best outcome prediction based on iPhone score. Then I decided to construct the light GBM myself since I can modify the parameters to slightly improve the performance. Mainly, I used the iPhone score on the cross-validation test set to assess the fit of my classifier. Soon I reach a bottleneck, which motivates me to go even beyond the models included in py-caret. And my goal is deep learning. My to-go is a deep learning model. And typically, what I choose three here, the IPN, CNN, and MMP to compare their performances. And after constructing each of them and compare their F1 score, I found that the FCN model gives the best predictions. And let me go backwards a little bit. And after choosing an operative model, I'm just wondering if the performance can be further improved by trying different oversampling methods. And I have tried Addison, borderline mode, mode, and SVM mode. And finally, the SVM mode gives the best outcome, and I will choose it to boost our minority groups. And as well as that, I try to modify the parameters in the arguments of the CNN model. And it turns out that the current combination gives the best outcome. And as always, that I've also tried log transformation on some of the numerical features thing, since they are right or left scaled, but it does not improve the overall performance overall. Hence, I dropped this step. And to sum up, the whole Python notebook achieves the target of predicting the stroke status by doing the data processing, balancing the uneven distributions of the outcome classes, and that's typically the SVM mode, and using the deep learning model CNN. And that's so much for the presentation. And thanks for your close attention.